Hi everyone, my name is Filippos Kozakos and this is my presentation for Lab 1. So let's get started. For our introduction, the purpose of this lab was to examine Newton's first law, the fundamental physical principles that consist of this law. So in our experiment, we put an initial force on the object and then let it continue its motion. What we concluded was that the object will continue to move at a constant velocity after we removed our hand, since the net force acting on the object is now zero. Also, Newton's first law implies that if the object was initially at rest, it will remain at rest if the net force is zero, which is something that is not covered in this lab. Here is my tracker model. So the tracker model analysis observations, I have set my x-axis to be on the right side. Therefore, the motion of the object follows the positive direction. That's why the values of x increases in the positive x-axis as the values of t, which is time, increases. The line of x, m, ts graph is linear since the object is moving at a constant speed without any net force or acceleration. So let's now discuss on the next slide how the results will change, or how they will change, or how they will remain the same if I had decided to interchange plus x-axis with minus x-axis. So how things will change in the direction of motion. Objects that were originally moving in the positive x direction will now move in the negative x direction. For example, if an object was initially moving to the right, it will now move to the left, minus x. Graphs. If we are to plot a velocity time graph, we will see that the line will be linear, parallel to the x-axis, and will have a negative velocity value over time. So how things will remain the same. Newton's law. The fundamental principles of physics, including Newton's law of motion, will remain unchanged. Conservation laws like the conservation of momentum and the conservation of energy will still apply. So can we determine how many forces add up to zero net force? The initial push, I apply the initial push, so the object will exit its state of motion and start moving. And then the balancing forces, once the object is at motion at constant speed, it implies that I have balanced the applied force with opposing forces, which are the following: friction and air resistance. This is my enclosed script model. You can find also here is a link that will take you to my code, so you can see the code. The coding, those are 3 pictures. Luckily, there was only a few places that I had to change the starter code. In the first image, as you can see here, while t is less than, I specify the time where the model will stop calculating the position. In the second picture, in the middle picture, I input the initial velocity vector and the initial position vector. In the picture at the bottom, I updated the velocity vector as well as the position vector. For the velocity, I have added the vector 0, 0, 0, since the object is moving with a constant speed after the initial force that I have put on the object. Finally, I updated the position by adding the initial position of the ball with delta r. So possible sources of error in this lab could be while conducting experiments like this, we must take into consideration friction and air resistance. In our case, we consider both of them as 0. Data and model predictions, similarities of the data and my data and the model outcomes are that both of them are consistent with physics law. Both data and model predictions are consistent with fundamental physics principles. Their pattern and trends follow the same ones. The difference is that the experimental and versus theoretical data are obtained through experiments and observations in the real world, while model predictions are theoretical based on mathematical equations and coding. Now, both models in the same graph. The time t is the same for both models. X1 represents the tracker's distance values, X2 represents the glow script distance values. We can observe that the outcomes of both models match, therefore the results verify the concept of Newton's first law. Conclusion, our lab experiment demonstrated that once initial force applied to an object and then removed, the object will maintain a constant velocity due to the absence of a net force. This observation reinforces the fundamental concept of Newton's first law of motion. Thanks for your attention.